Hi everyone, my name is Thomas Kim. Today is July 23rd, 2021. This is 31st episode about modern C++ experiments. This is also 10th episode about C++ rational numbers. We will implement member accessors, also increment and decrement operators. If you haven't watched my previous video, episode 30, Rational numbers 9, integration with three-way comparison operator, please double-click this link. In this video, we integrated three-way comparison operators for comparing rational numbers. Scroll down, show more. In the download source code section, episode 30, please double-click this link. Show in folder, unzip it, rename 031 member accessors. Copy, paste it in your working folder. Start Visual Studio Code from folder 31, rational.hpp, rational.cpp, Ctrl V. I will arrange side by side. In the file rational.hpp, Ctrl F, press tilde. We found destructor. Close it. We will define Boolean operator. constexpr, bool, operator, const, noexcept. We are testing if numerator is not 0. If numerator is not 0, returns true, otherwise false. Now here access numerator, constexpr, const element type, num, const noexcept, return this and num. Copy, paste, access denominator, denominator, return old value of the numerator, set a new value. constexpr, element type, num, element type, nv, new value, noexcept, or old value, this m, num, this m, num, new value, return old value. This is wrong. Very wrong. We have to call reduce. Return old value of the denominator. Set a new value to the denominator, to the numerator. constexpr, element type, denominator, element type, new value, noexcept, or old value, this m, denominator, this m, denominator, new value. Don't forget calling reduce. Return old value. Critically important. Also very important. Now free increment operator. constexpr, constant element type, L value reference operator plus plus. This increment by 1, then return this. Increment the value by 1, then return the updated value. Now pre-decrement operator. Decrement the value by 1, then return the updated value. minus minus. We decrement by 1. Now, first increment operator int. Increment the value by 1, return the old value. constexpr element type operator plus plus int. Sorry, go up. It can be noexcept. Also noexcept. Also noexcept. Or old value this. This increment by 1, return old value. First decrement operator int. Decrement the value by 1, return the old value. constexpr element type operator decrement int noexcept. Or old value this decrement by 1, return old value. Now let's double check. We defined negation operator as Boolean operator. So here void test member accessors. Copy the function name, paste it here, disable it using rational t rtn rational int rational t a initialized with default value std cout a std and there. If a, it means a is not 0. std cout a is not 0. std and there. Now in the command prompt, clexc std c++ latest rational.cpp fe m.exe, hit enter. M. Sorry, I will add another Boolean operator. constexpr operator bool const noexcept. Return this num is not 0. It should be this. If it means a is 0. A is 0. Let's try this. We rebuild CLSM. A is not 0, but A is 0. Numerator is 0, so this message is not displayed. But this message is displayed. Okay? Please remember this. Or if we initialize with 1, we rebuild M. A is not 0, so this part is displayed. If this is 0, we rebuild CLSM. A is 0, so this message is displayed. I am terribly sorry. I will create another function, bool valid, return m denominator is greater than 0. Denominator can never be 0. The rational number is invalid state. Here, valid and not 0. So, valid, not 0, and valid. Valid and 0. 0 and valid. I will change the order. Also, I will change the order. Valid and not 0. Valid and 0. So, valid and not 0. Valid and not 0. Valid and 0. Valid and 0. If A valid, std cout A is a valid rational number, else A is invalid. We build again. CLSM valid and 0 because numerator is 0. Now I will copy this part, copy, paste, member access 2. Copy the function name, paste, disable. We are testing member access function. Rational TA, we initialize 0, 5. std cout A, std, enter. std cout A, numerator, A, numerator, A, denominator, A, denominator, std, enter. We will make line break here. Now we build again. CLSM. Please note very carefully. We initialized A05. Our result is A is 01. Okay? So we adjust. Denominator is 1. Denominator is 1 when numerator is 0. Numerator, denominator, it works correctly. Now we set A num 5 or A num old. std cout A std enter. std cout A old num. A num old. std enter. We build again. CLSM. So from this state we set 5 new value to the numerator. So 5 1. A old numerator 0. This value. Now or A denominate old. A denominate 3. std cout A std enter. I will copy this part, paste A old denominator. We are testing this function and this function. We rebuild sorry, this value, CLSM, we set 3 to denominator. So from old denominator 1, old denominator is 1, new denominator is 3 because we set 3. Now we are testing increment and decrement. Void test increment decrement. I will make it big. I will copy this, copy, paste, copy the function name, paste it here. Here we can say for rational TA, this does not work. We have to initialize like this. A less than 10. This does not work. This is rational number. This is integer. We have to rational T 10. Then plus plus A STD C out A STD C out STD and there. We have to make a few changes. Now scroll up. In the constructor, this constructor has one parameter. We need explicit. This explicit is important. Now we build again. Sorry, 191, 191. We will remove and fix like this. Also, remove L value reference. Now we rebuild CLSM. So this is our rational number. 0, 1, 2, 3, up to 9. Please note that it does not work. Let's try with a clang compiler. Here, error. We have to fix like this. Then we try again. CLSC. Using GNU compiler. GNU compiler also works. Please note that A is rational. 10 without rational does not work. Now we test decrement. Rational TB, we initialize 10 while B is not 0. STD C out B decrement STD C out and there. We defined this operator, Boolean operator, I explained here. So if B is not 0, this loop iterates. We test with Microsoft compiler. Sorry, STD and there. We build again. CLSM. So our loop iterates from 10 to 1 with this. Or we can say greater than or equal to 0. We have to use rational T This is 0. We build again. CLSM. Now 10 to 0. We have to compare with a rational number. In the same manner, using GNU compiler also works. In this case, we used decrement. In this case, we used increment. We can also use post-increment, post-decrement. We build with Microsoft compiler. The result is the same. Using GNU compiler, the same. Clang compiler also works. Sorry, I made very silly mistake. Element type. It should be constant, rational, L-value reference. Also, constant, rational, L-value reference. Scroll down. It should be rational. It should be rational. Let's try all test. I will enable all. Now test with Intel compiler. Copy, hit enter. CLSD. Intel compiler builds successfully. Control Home. Intel compiler command line. Microsoft compiler CLSM. Microsoft compiler also builds. I will copy command line, paste it here. Now Clang compiler CLSC. Clang compiler also works. Copy, paste. Now GNU compiler also works correctly. Copy, paste.